hello, everyone. Welcome to my presentation, and hope you enjoy the ALX Logistics Conference. Okay, so let me start with sharing my slides. Hello again. So I'm Dmitry. I'm professor for supply chain and operations management at Berlin School of Economics and Law. And I'm happy to share with you some recent insights related to the design and application of digital twins for supply chain stress testing and resilience using ALX Logistics. This talk combines my two major research topics, which you can also associate with two books visible on this slide. On the one hand, I'm interested in supply chain resilience, and on the other hand, my research interested in the area of the digital supply chain. With development of digital twins for supply chain stress testing and resilience, these two topics are merged, and this is why I decided to select this topic for presentation today. I structured this talk following the logic which begins with general overview of the digital supply chain technologies, particularly focusing on digital supply chain twins. It will be the first part. In the second part, you will see some application examples in ALX Logistics. And I would like to extend discussion looking a little bit into the future, what intelligent digital twins and human artificial intelligence interface. So in contrast to the first presentation today, I will not present any concrete model. I would rather summarize generalized insights from different models which we have developed for the last years, and take an extra step trying to predict how development of the digital twins will happen in the next years. Digital twins, digital supply chain technology became a very popular topic. In our recent work, we tried to summarize and classify different technologies and their applications in supply chain and operations. And so we came with this matrix, which aims at classification of digital supply chain technologies into 6 distinct categories, which are infrastructure technology, communication technology, automation technology, identification and alert technology, data processing technology, and collaboration technology. Interestingly, we see applications of all the 6 technologies at 2 levels, at the network level and at the plant level. And you can see that we have a variety of digital technologies, starting from the infrastructure created through Internet of Things, 5G, cyber physical system, then going toward communications, mainly implemented through blockchain at the network level, or sensors, product sensors, for example, at the plant level. There's a lot of automation technology, which is obviously available only at the plant level, like additive manufacturing, collaborative robots, drones, mobile robots, AGVs. We also have identification and alert systems, which are especially important for resilience, like early warning systems, which inform us in advance about possible disruptions in future before the real disruption really hits our supply chains. Then we talk about data processing technology, first of all, big data analytics. And finally, important is collaboration technology, for example, collaborative supply portals. All in all these technologies equip us with principally new possibilities, something what we have not seen, say, for 10 years. With possibilities to collect and use data. And one concrete implementation of these technologies are digital twins, right? So through work with companies for several years, I came to the conclusion that actually there are 5 major types of digital twins. which you can see on this slide. So most of companies have digital twins of their products, right? Computer models, 3D models of the products. Many companies have digital twins of the processes, like manufacturing process or warehouse process. Quite a few of companies I have seen have digital twins of their organizations. What the companies are really missing and what they are looking at are digital twins of supply chain networks, and moreover, digital twins of networks, meaning infrastructures that are used by different supply chain. Like, for example, digital twin of European transportation network, something what is used by different supply chains. So companies are interested not only to create digital twins of their own supply chains, but also digital twins of the networks, of the infrastructures they use in their operations. What is digital supply chain twin? So definitely it is much more, it's just a simulation model. Digital twin of a supply chain, it's a virtual system which is comprised of three major components. First, it is virtual representation of physical objects, so visualization of a physical supply chain. But it's not only that, right? It's not just a digital replica of a physical object. The second element is technology, digital technology. So data about the supply chain from Internet of Things, blockchain, sensors, cloud, ERP. And the third component is analytics, descriptive, predictive, and prescriptive analytics for decision-making support. So with the digital supply chain twin, we understand a system which represents physical objects, represented with real-time data, with digital technology, and uses this data for descriptive, predictive, and prescriptive analytics. In many presentations and many keynotes which I gave in the last years and in the lectures, practitioners and researchers ask a very simple question. What is the difference between a simulation model and a digital twin? So, of course, simulation is a very important part, central element of digital twins. However, digital twins differ from standalone simulation models in several aspects. First of all, digital twin is supported by a real-time technology, which implements data collection. You can continue this data collection, processing, labeling, visualization, and generation. Second, digital twin, it's a combination of different models. It's not just a single model. So digital twin includes not only internal data, so it's not only offline modeling, but it's pre- and post-processing of data in integration with external systems. I will show you some examples of this system just in a few minutes. And finally, last but not least, and probably even the most important part, it's knowledge. Digital twin, it's a knowledge-driven, knowledge transferring, and very important knowledge creating system using human-machine interface. Especially knowledge creating through digital twin seems to me a direction of developments in the next year, and I would like to stress this aspect in one of the next parts of this presentation. Let us take a look at the digital twin for supply chain stress testing. This is a conceptual model, which in the next slide I will put into the world of annual logistics. So essentially we have two areas, disruption data and model. Disruption data is something what exists outside. It can be data about strikes, financial crisis, any natural disasters data like floods or storms, power outage, for example, fires, man-made disasters. Right? So, and this is the first part. And the second part is the model. Usually it's a combination of simulation model and optimization models like in any logistics. All this data which actually represent disruptive events are filtered through some big data analytics, machine learning techniques, and then they go as events, for example, into simulation model or as parameters of a constraint system into the optimization model. Every time when we start optimization or simulation, we do it with real-time data. Outcomes of simulation model can be, for example, suggestion on the best reactive recovery policy, how company should react if a disruption happens. Or optimization can be used to proactively design a resilient supply chain, right? So such an approach can be used both in proactive and reactive directions. So if we use a digital twin for improving our supply chain, so before real disruption happens, right? So we are just trying to strengthen supply chain in advance without waiting for emergency case. Here we can use past data, we can use some statistical data about disruptions in the past, and so trying to make some stress test of supply chain, understand how resilient our supply chain is to such disruption. So we make some prediction and analysis. If a real disruption hits our supply chain, then we look into real-time data, right? We monitor our supply chain, and once we get alerts, when we get signals about disruptions, we utilize real-time control. Right? And the outcomes of the modeling can be further processed through business intelligence applications, ERP applications, so some additional performance evaluations tools. So this is a conceptual topic. Now we look at the annual logistics digital twin. So we published quite a few papers on that, and this slide nicely summarizes the principal idea of stress testing supply chain using digital twins. So again, we have on the one hand supply chain model done with nano logistics, the simulation optimization models. On the other hand, we have risk data, which are external to our system. Just imagine we get two signals, right? There are two disruptions, like for example, tsunami in South Asia and fire or strike in another part of the world in North America, right? So we immediately map this risk data and supply chain locations to understand, are these disruptions relevant to us? And if yes, then we are running simulations, we select best possible recovery plans and analyze impacts, performance impacts of our recovery policies for the supply chains. And again, so it can be used both in proactive models using historical disruption data for stress testing of supply chain to understand possible performance impact, and it can be used in the reactive model when we get real-time disruption data, and our main task is to select the best recovery plan, understanding performance impact of our decisions. So now I would like to focus on some generalizations and some future-oriented considerations where digital twins can be developed in next years. There are three levels of digital twins. The first one is so-called, we can name it major digital twin, right? So this is something what we now have in any logistics. On the one hand, we create a visual model of our supply chain, and on the other hand, we use this model for optimization, simulation, and forecasting of how our supply chain can react if different disruption happen. Right? So this is the first level. This is what we have now. The next step is cognitive digital twin. The cognitive digital twin is the same as a digital twin, plus it mimics human decision-making rules and suggests some action plans. Simply put, traditional digital twin, like a simulation model, would produce some simulation, and we as decision makers will receive some performance indicators, we receive some numbers based on which we should make decisions. So digital twin does not suggest any decision support for us in this case. The cognitive digital twin mimics human decision-making rules. It does not only compute solution, but also suggest action plan, how to implement this solution in real life. Simply put, digital twin can compute us that if a particular disruption scenario happens, our on-time delivery would be reduced to 80%. And then we should think about what to do to avoid such a reduction. Right? Cognitive digital twin would compute that on-time delivery will be reduced by 80%, and at the same time, it would suggest us where and what in the supply chain should be changed to avoid such a disruption impact, and it would give us a suggestion of recovery policy. So here we have an element of artificial intelligence. However, we don't have here a very important feature, which is knowledge creation and self-learning. So all the suggestions which a cognitive digital twin will give to us are based on human knowledge, on our knowledge, which we put into the computer system. So computer system just mimics it. And here we come to the third level, intelligent digital twin. The same as cognitive digital twins, plus it does not only mimic decision-making rules designed by a human, but also creates new knowledge and new decision-making algorithm through some self-learning and human AI collaboration. It helps humans understand the system better and can even take over some portion of decision-making. And intelligent digital twins is a direction for future developments in this area. So we want not only to replicate our own decision-making competence, our knowledge about system, because our knowledge is limited. We never know everything about system. Digital twins should help us to understand system better. And digital twins should be equipped with capabilities to learn about the system and to learn about evolution of the system. More or less, here we come to the area of collaboration between human and artificial intelligence. Sometimes digital twin can take decision. Sometimes digital twin can say, "Oh, sorry, so I don't know much about the system, so perhaps at this stage, human would make a better decision." Right? So these are three areas of digital twins. And finally, I would like to connect these three levels of digital twins with three kinds of resilience system. If we talk about digital twin, we can name it resilience system of the first kind. The ability to react when something happens, and whenever the operational performance passes a certain threshold identified for monitoring. Well, more or less, we have a disruption. We see that because of this disruption, we have some performance degradation, like on-time delivery. It's reduced by 80%, so it passes some certain threshold. When we look at the cognitive digital twin, we talk about resilient system of the second kind, systems that learn from what happened to adjust future responses and monitoring rules. So in that case, a resilient system would not only see immediate performance impact, but it would learn from our reaction, it would learn from the disruption, from the system response, and in that way, it would improve decision-making rules and future responses to disruptions. And finally, when we look at the intelligent digital twin, it is a resilient system of the third kind, which we name the viable system. Here, the major component is the ability to anticipate, to proactively mitigate disruption before they hit supply chain. And this is a key difference. A resilient system of the first kind reacts after something happened, after disruption happened. A resilient system of the third kind, the viable system, tries to avoid disruptions based on real-time data which we get from different systems about the supply chain. So in that case, resilience becomes a property of the system. So it is a quality. It is not just a quantity, which we measure by performance deviation. Right? So it becomes a quality of the system. And the focus shifts to adaptability and performance persistence, more or less, to the ability exist or not. Right? So intelligent digital twins integrate monitoring, event-driven responses, learning, and proactive thinking based on human and AI collaboration. Simply put, digital twins can help us make unknown known. Right? So uncertainty, unknown is a key problem in resilience. Right? Just a very short excursus to the systems theory. In the systems and control engineering theory, each system is divided into two spaces, the system space and uncertainty space. System space is something what is under our control. It is controllable, observable, and predictable. Uncertainty space is outside of our control. Right? And uncertainty can be different. It can be known uncertainty, like, for example, demand fluctuations, where we can describe uncertainty with some probability functions like normal distribution or log normal distribution. Anyway, we have some data to make this uncertain more or less known. But there is a lot of unknown uncertainty. Right? The COVID pandemic was a very good example of this unknown. No one has predicted it, and no one knew how this disruption will develop. And there are more and more such unknown uncertainties, and they are uncontrollable, unobservable, unpredictable. And here the essential question is it wise to manage resilience focusing on the unknown, uncontrollable, unobservable, unpredictable? Or perhaps it is better to focus on the system space, what is under our control, building supply chains with structural variety, process flexibility, efficient redundancy, concentrating on controllable, observable, and predictable. So, and in this case, digital twins can help a lot through supply chain mapping, illuminating digital shadows, for example, illuminating some hidden suppliers, disruptions of which are very dangerous, and some proactive disruption recognition. Digital will help make us unknown. And what we are doing in different projects is basically the development of the intelligent digital twins based on human AI collaboration. And here, both logistics and logic play a crucial role in developing supply chain analytics model, in developing artificial intelligence parts of the digital twins. To summarize, supply chains are exposed to disruptions, and as we see now, there are more and more disruptions, and severity, scope, scale of these disruptions increases. Disruptions can be both positive and negative. The positive disruption is, for example, development of digital technology, like Industry 4.0. And negative disruptions is something what creates negative impacts on supply chains, like a pandemic, for example. Digital technology and resilience as two areas oriented to disruptions, positive and negative disruptions, are transforming supply chains towards reconfigurable, adaptable, and resilience-centric networks. Digital technology can help us to achieve end-to-end supply chain visibility, which is of great value for managers, both at normal times and at the crisis times. The research what I presented, on the one hand, it helps to solve the immediate problems companies have. But on the other hand, it also develops new methods and infrastructures for solutions of future problems. And this is actually what good research should do. Future areas which I can see here is that we are moving more and more from offline modeling toward data-driven digital supply chain twins. A very important part in the next year will be we can see in human AI collaboration. And in the end, from the management point of view, we all are interested to understand the role and value of real-time data for decision making. How a future supply chain manager will take decisions. And we hope with our technologies, with digital twins, with any logistics, to contribute to this crucial area of practice and research. I think it is the last slide, and I hope it was useful for you. I will be happy to answer questions, if any, and thank you for your attention.
Great, thank you very much. There are a couple of questions here. I don't know if you can see them, or you would like me just to ask you them.
Okay, so yes, I can see chat. So, okay, so the question, for example, what are requirements for digital twin? What kind of information should be collected before we can call our model a digital twin? Yes, it's a very crucial question. Indeed. So first of all, we should. So I would limit my answer to the supply chain digital twin, right? Because there are many digital twins, product, process, networks, and they would require different kind of information. Limiting my answer to supply chain digital twin. So first of all, we should describe the physical supply chain, right? So we should get enough information about the system we want to represent digitally. It seems to be easy, but not so easy in real life, right? So real supply chains are multi-echelon systems, and say focal companies or regional equipment manufacturers, they not necessarily know all the suppliers in their supply network. They might know the first tier supplier. They might know some of the second tier supplier based on some, contracting or machine tooling activities. And it's quite unlikely that they will know who are their suppliers on the third, fourth, fifth, and so on tier levels. It is much easier in the downstream part of the supply chain, right? If you look at the logistics and distribution networks, here we have quite a good data quality, data accuracy, basically, which we can use data from logistics service providers, from logistics company. It is quite centralized system with good data accuracy. So here we can develop good digital twins. For upstream part, right, when we look at the suppliers, we don't have this quality of data, we don't have this degree of centralization and a lot of decentralization. So it's getting difficult. So first of all, the requirement is to represent as much of your supply network as possible. And the second requirement is for particular analysis purposes, to understand how you can obtain external data. And external data depend on the context. If you analyze resilience, you need data about potential disruptions, right? Data about natural disasters, data about human-made disasters, data about maybe financial disasters, and so on. Right? So if you analyze sustainability, you need another sort of data. So more or less, to put it very simply, you need two types of data about the system and data about the environment, right? So, and usually we are more successful in designing digital twins where we have centralized part of supply chains, which usually have better data